This is the tale of a tired teacher and a smart student. Once upon a time, near the end of a very long school day, a teacher with a horrible migraine assigned her students a task that she hoped would keep them busy the rest of the day. The teacher told her students to find the sum of the numbers 1 to 100, and just to be evil, added, "No calculators." As you can imagine, the students were not happy. One little boy, though, ingenious as he was, in a matter of seconds had the computation, and just to be nasty, sent the answer soaring to his teacher on a paper airplane, destroying the teacher's dream of a peaceful end to the school day. Now that little boy would grow up to become a world-renowned mathematician, Carl Friedrich Gauss. Now, Gauss was considered to be one of the greatest mathematicians of all time. During his lifetime, he made significant contributions to almost every area of mathematics, as well as physics, astronomy, and statistics. And, like many great mathematicians, Gauss demonstrated amazing mathematical skills from an early age, and there are many stories relating how very, very clever he could be. And of course, the most famous story was this tale about the 1 to 100 sum. With astonishing speed, he came up with the answer of 5,050. Now, this begs the question, how did Gauss manage to find the correct answer so quickly? To analyze Gauss's thinking, let's start by looking at a smaller example, adding the numbers 1 to 5, and let's use a graphic to help us visualize an intuitive approach. So, we might show one block, and then add 2 blocks, and next we add 3 blocks, and let's organize them in a staircase fashion, as we continue on to 4 blocks, and finally adding our final number of 5. Okay, stay with me here because we're going to do something that won't make immediate sense. Create a duplicate staircase, then rotate the duplicate, and puzzle fit the 2 staircases together, forming a rectangle. The dimensions of this rectangle will be 5 by 6, and we can quite easily compute the area of this rectangle. Now, unfortunately, this rectangle has double the amount of squares that we need. So, to find our original blue staircase, we'll need to take the area and divide it by 2. Thus, we've shown the sum of the numbers 1 to 5 to be 15. Let's look at a few more examples, like looking at the sum of 1 to 6. After creating and manipulating its duplicate staircase, we see a rectangle with dimensions 6 by 7, giving a rectangular area of 42, meaning the answer to our question is half of that, 21. Continuing to look at these sums, let's look at 1 to 7. Making and manipulating the duplicate staircase, we get a rectangle with an area of 56. That means the blue staircase would be 28. And now let's look at one final smallish example. You guessed it, a staircase representing 1 plus 2 plus 3 up to plus 8. And that in turn leads to a rectangle of area 72 and a final computation of 36. Of course, it's all well and good when you have pretty small numbers, but we'd like to have a closed formula that would allow us to compute the sum of 1 to any number of our choosing. In other words, can we quickly find the sum of 1 plus 2 plus 3 plus all the way up to plus n? If you use the same process of duplicating this imaginary staircase, we would get something that looks like this rectangle, a rectangle that has a dimension of n and a dimension of n plus 1. So, to find the area of the rectangle, we multiply n by n plus 1. And get ready for our final step. We take that area, which is double what we actually need, meaning the area of the blue staircase would be half of the area of that rectangle. And looky, looky, looky. We now have a closed formula. The sum of the numbers 1 to n can be quickly computed by finding half of the product of n times n plus 1. Whoop-de-doo, and bam! My brain hurts a bit. Seems like a good time for a math joke. What do you call a number that is always on the go? Ready? Wait for it. Wait for it. What do you call a number that is always on the go? It's a Roman numeral.